Hello Internet! In this video I wanted to go through and scrape some stock data, but instead of using something like Python, I wanted to mess about using Unix because sometimes you don't have Python installed and you need to do something quickly to get some data, as I had to do the other day. So in this case, there are a few challenges with this website I want to scrape. So I want to get some stock data. I want to get these codes here for the FTSE 100. This will all be linked in the description as well. The challenge with this website is that the data we're getting is paginated, so we're only getting like 20 results per page. And the other problem is that if we look at the data, so if we inspect it, we can see that it's got this ng content stuff. That basically means it's Angular behind the scenes, which is JavaScript ultimately, which renders this table. So if we were to use something like Python requests anyway, you wouldn't get any data because it wouldn't load the data. You'd have to directly call the endpoint. And the problem with that is that they're often secured. I don't think this one actually is, so it doesn't rely on having a cookie, but in any case, we don't even need to bother with using Python for this. We could use Selenium if we wanted to render the data, get it from the table using Beautiful Soup. Totally could do that. But again, there are cases where you might not be able to do that for various reasons, like not having Python installed on the system you're working on. So if we look at the network tab, have a goosey gander at this. I've got the network tab on, and I've got recording set on, so that's Control E or Command E. We can see that there's a post request being made. If you look at that, look at the response tab, you can see that there is a response that contains a whole load of data in there. It's all in JSON format. Lovely jubbly. And if we look here, we should see that I've never even heard of that company, but they're right there. That's the first one in the table. So this is the data we want. So if we quickly copy this, so copy this as curl, we can have a look. If we go to our terminal, copy that, enter it, bang. If you're on a Unix system like Mac OS or a Linux system, you will have just seen all the lovely data show up. And we can see here that we've got Berkeley Holdings Group in this page of data. So if I create a shell script called scrape.shell, and what I'll do here is, great, I have ballsed up copying that somehow in the meantime. Oh well, come back and I'll do that. If I quickly run that, we should see that we get the same data again. We do, so it's all working. What we want to do though is we need to get different pages of data. Now there is something in here that I've just spotted, size 20. Now I'm not sure that this actually is going to provide us with usually, let's have a look. This is providing us with 20 things for each page. So what I'm thinking is, if I was to just change this to 100, would this then return us with 100 things of data? I don't know. Let's have a look. So if we do we run the script from outside of Vim, and what we're going to do is we'll pipe it to we need to pipe it to something called sed, because all of this is coming through in one line. Well, we don't need to pipe to sed, but this is just an easy way of doing it. So pipe it to sed with the -e option, and then we give it the substitute command. So that's s / then the thing you want to match. In this case, I'm going to just do a comma, and then /, and then I want to give it \n for a new line, another / to say I'm done replacing stuff now, G to say everywhere, although I don't think I even need that. What that should now give me is a line of data, and it does. So the reason I wanted that is so that now I can pipe this to something else. So if we repeat the same, what the hell? Well, that was an absolutely epic. Wow, how did I just lose what I just typed? That's anyway, we'll type it again. So we'll run that file again this way. Scrape.shell. Annoying that I've got to type this whole thing out again because it's just lost it. I don't even know how it's happened. But we'll type it again. So I want to match any comma /, replace it with a new line, do it globally. From there, I want to grep out for something that's in the company. So if we look back at the page of data we get, well, I'm looking for the code. So where are they? So there's a description there. It's the TDIM, TIDM codes we're looking for. So if I grep for that, so if we do TIDM, we should see, we get a load of data. Now I've changed that to 100, remember, and we've only got what looks like 20 results back, I think. So we could do WC minus L to get a count. Yeah, 21, so including that line which has showed up, which we don't care about. We've got 20 bits of data. So changing that number didn't have an effect, which is a bit weird. So what we'll have to do instead is we're going to have to change this script a little bit so that we can give it a number. So if we go to page again, I need to give it a page number. Now I've noticed this is in two places. We've got page here, which is in the parameters, and also in the parameters for the thing directly below the cursor. So what I need to do here is replace this 1 with an interpolated string. So close off the quotes, open a new set of double quotes, do $1, close off the double quotes, back to the single quote so that everything is joined up nicely. And then it's one line, so global down for Vim. Press the dot command. Does that work nicely? It does. We'll get rid of that 1. Pip, pip, pow. So what I've just done is we're going to replace, this is going to be a number we pass into a function which we've yet to create. So if I go all the way to the top, call this get, move it to a function, go down to the bottom, close the thing off, indent everything nicely. And now if I was to do something like call, let's just create another function called test real quick, just so you can see what happens if you're not familiar with this. So we'll do test, and I will do here something like echo S1, right? And if I call test that, it prints that to the console. If I was to do S2, right, what this should do, and we'll add another thing at the bottom, so we'll do something like hello, do this. It now prints the two things because it's figured out that the two parameters I've passed to this function, it knows that this is S1, well this is $1, this is the second parameter, right? So all we're going to do is we're going to pass in a number to get. But we're going to do that from outside the script because we want to call it from a for loop. But we don't have to do it from outside the script, but we can do. So if you do get and then just give it $1 again. Now $1 isn't defined anywhere here, but if we would come out of this script and I was to call it normally, we could call it normally like this and do shell and then give it 1. And look at that, it takes some data and it gets everything. So what we can now do is get all the data. So we need to call that script 5 times. How do we do that? Well, we can do for I in and then 1, 2, 5 like this, semicolon, then call do, and then if we say echo I, so $i, close that off and just call done, we get 1 to 5. So now if I come back and instead of doing that, we replace it with the call to scrape with $i, close that off, call done. But what I then want to do is I want to then save the data so we're not constantly calling the endpoint. If we do the less than greater than sign, whichever way around it is, I never know. The crocodile thing, if we do that and call it FTSE 100, we're going to get some JSON out of that. I've cocked that up because I didn't type in .shell. There we go. And you can see that it's called curl 5 times by the looks of that. Let's have a goosey gander at the data we just got back. It's JSON format, it's not very readable. One thing you can do here, so I'm in Vim. If I call %, exclamation mark JQ dot, oh look at that. That's beautiful and really nice and lovely. Nicely formatted now. If you need that on the Mac, you can do brew install JQ to get that, or if you're on Linux, it's adb get install JQ, but it will depend on whatever flavour of Linux you're on. If you're on Linux, you probably already know that anyway, so probably wasting my time telling you that. But let's suppose that you can't get that for whatever reason. I'm going to assume you can't get it, so we'll carry on as if I don't have it. So if I just quickly recreate that same file and don't bother formatting it. So I've got it back as it was. We can now proceed to get the data we wanted. So how do we do that? Well, let's think about using our friend's Sed. Sed is a Unix tool. It's very useful. Sed -e, and we're going to substitute. In this case, we want to do substitute comma for a new line, just so that we've got everything on one line. If you've just used JQ to make it nice, you don't need to do this one. But that should, if we give it the right file, make everything on a new line, as we've seen before. But what I now need to do is now I need to get rid of all of the stuff that I don't care about. So how do we do that? Well, I care about the TDID, TIM, whatever the hell it is. This one, this file here, this line, this bit of text. I care about that. So I want to grep for that. And I find that. Now, that's got everything we want. That's got all the tickers, and you can see that we've got 20 tickers here, we've got 20 tickers up there, and then more above there. And we've also got these lines that we don't want. So we need to get rid of those lines we don't want. So we go back to the same thing. What I think the best thing to do here to get rid of these things is to call grep again. But instead of calling grep and saying I want to match anything that has TDI that in there, I'm going to say ignore anything that has these squiggly brackets in. So -v option to invert the match. So don't just ignore the things that match this. If we do that, we should get everything gone. The colouring's gone because of just piping too many greps. It's quite annoying when it does that. Although I think you can give it the dot colour option and it should be fine. The dash colour option, it should still do it. What we now need to do though is we now need to get the data we want. So we need to pipe this again to sed. So sed -e, and we need to substitute. So do substitute and backslash. Backslash is to escape something, so in this case we're escaping double quotes. We're going to get rid of TDID, again get rid of the next double quotes, get rid of the colon, get rid of the next double quote, substitute that for nothing. So I could say, you know, hello world, and that's what I'm substituting this for. So it's like a find and replace. But if I do nothing after that second slash, it's going to just replace it with nothing. So we can run that, and you can see we've got everything we want, except we've still got the quotes on the end. So how do we get rid of those quotes on the end? Well, guess what? We just pipe to sed again, and of course we just do same thing again. Substitute backslash double quote with absolutely nothing. Absolutely nothing. Say it again now. And I've messed something up. Oh, what I've messed up there is oh, I haven't actually messed it up, although I did mess it up at that point. We can do that to close off the single quote. Ooh, bad flag. Why is that there? Because that shouldn't have been there in the first place. And there we go. What we can now do is let's send that to a file called codes. Cool. Find the codes. Wonderful, lovely, jubbly. And if you wanted to count them, you could do cat codes and do WC -L 81. That doesn't quite seem right. Why doesn't that seem quite right? I suspect because we've missed out some data. So let's look at our for loop, and the classic error is going to be almost certainly that the index for page 1 is actually is 0. So let's see if we can fix that real quick. So do the for loop again, and let's switch this out to 0. It's going to do that. It's going to call it 6 times. So that last one probably got nothing back, which is probably about right, considering that it didn't get as much data back. We can see the first one got about as much data as the other one, so that's probably about right. That's probably what we're looking for. What, of course, we can do now is we can do that exact same thing we just did on the file called codes, and if we do cat codes WC 101, so that's about right, because we don't actually always have exactly 100 companies in the FTSE 100, and you can see that looks a little bit better. And so that is one way of getting data from websites in the case of not having to use something like Python or not faffing around. And obviously as I was talking through all that, it took a little bit longer than it would have done if I was just doing it myself. And as you can see, when we needed to change something, it was just a case of recalling the script and rerunning that sed script. And you could also move all of this sed stuff we did to a new, to the script if you wanted to, and you could just keep running it whenever you felt like it. So hopefully that's been mildly interesting. It's quite useful, especially how powerful Unix is. So just to review what we've done, we have used the curl command to get some data. So the curl command there. What we did is we also interpolated some strings using basic interpolation in bash, which is in where we saw things like $1 in the case of the script. So back to the script, we did this string interpolation over there where you can see it's all nice and yellow, that string interpolation. And so this string here is single quoted, but we've escaped that, put double quotes around this thing because that's how you get variables out, and then back to the single quotes for the rest of it, just so it's nice and easy to do. We've also seen the use of the sed command, although very basic, where all we're doing is substituting stuff that gets passed to it. So in this case, all we're doing here is we're substituting all the commas for new lines. So sed is, here's the command we're running, and here's the data we're running it on. We've seen the pipe command quite a lot. I didn't talk too much about this, but the pipe command takes the output of one command and puts it into the next command. So there's this concept of standard in and standard out in a Unix system. So here we're getting a load of data. This comes out of this command to standard out. When we pipe something, we take what's coming out of standard out, i.e. coming out of a command, and going into another command. So in this case, you could pass it to grep. Grep is also something we looked at. Grep's a standard Unix utility. It enables us to basically search for things. It's quite useful. It enables you to filter things, which is what we were doing. So we've just filtered all the text. We can see what we found. Of course, then you can pipe that again and keep doing things. And that's what's really great about this. It's quite easy to do. Doesn't take much time. Unix is really great. So hopefully this has been somewhat interesting. Arrivederci, buongiorno.